Hello, and welcome to the SanteSuite video training series. In this series, we're aiming to give you a foundational knowledge that you're going to need in order to successfully implement and extend SanteDB platform products in your digital health ecosystem. My name is Justin Fife. I'm the lead architect and community lead for SanteSuite Incorporated, and I am so excited to be your host as we dive deep into these powerful and extensible components in the SanteDB platform. But before we learn how to deploy and extend SanteDB, we have to have a foundational knowledge. So without further ado, let's start our introductory module into the SanteDB platform. First, we'll begin with a little bit of a history lesson on SanteDB. I find it really helps to understand how a software is designed and why it fits together that way if we understand the history of that product to understand its lineage. Next, we're going to look at the major components of the SanteDB platform and how they fit together in a typical SanteDB deployment. This will give you some understanding of what the further videos are going to be talking about. And finally, in this video, we're going to take a look at how SanteDB is extended and how we package together those extensions into something called a solution which lives in the SanteSuite realm of the SanteDB community. First, let's take a look at the history of SanteDB. SanteDB began its life way back in 2008 at the mHealth and eHealth Development and Innovation Center, or the Medic Lab, at Mohawk College in Hamilton, Ontario, Canada. At the time, the Medic Lab was tasked with prototyping a reference implementation of the Pan-Canadian Electronic Health Record Blueprint. This required the creation of several stub services which we demonstrated working together in 2009 in our very first version of our reference implementation. Out of these initial versions, two products would emerge. One was the Medic CR, and the other was the Medic Shared Health Record. Both of these reference implementations shared a common service core framework, which handled auditing and database structures, as well as basic messaging. However, both of these products were maintained as separate source code repositories. This meant that each time we would have to do a new reference implementation, we would need to spin up a separate source code repository and another project based on Service Core in order to implement a new domain. Less than ideal. In 2014, we started to contemplate the idea of a common clinical data repository that would allow us to share common data persistence features and functionality between new reference implementations that we would be sure to have to build. So, in 2015, we began the new Shared Health Record initiative. This initiative was aimed at coalescing together the different functions of the different reference implementations together in a single cohesive platform. In late 2015, we decided that it would be better to focus our generic CDR concept on a particular healthcare vertical in order to iron out and sort out all the features, data, and behaviors of the system and how they could fit together. In 2016, we began to implement OpenImmunize, now known as OpenIZ, in Tanzania as the Tanzania Immunization Registry. In 2017, this work was piloted and then rolled out across Tanzania in different regions. OpenIZ was the birthplace of a lot of the concepts that you will see in SanteDB, including the disconnected offline functionality, which was expressed in Teamer and OpenIZ as a disconnected Android application. As OpenIZ was used in Tanzania, of course we found all kinds of issues with our original design. This was expected. And in 2018, we began the process of creating what would become SanteDB. SanteDB was based on OpenIZ. However, our first task was to genericize OpenIZ so that it wasn't just an immunization platform. We began to fork the code base and clean up a lot of the version 1 code that was common in OpenIZ. This included bringing in a second vertical, the master patient index from MedicCR, in order to validate that we were truly genericizing OpenIZ in a way that was meaningful. Additionally, we upgraded a lot of the code base in OpenIZ to use .NET Standard. This was key as we wanted to share code between both the central server and the offline disconnected clients that were all around Tanzania at the time and around our other projects that we were doing in Myanmar. So what are the differences between OpenIZ and SanteDB? Well, the first is that OpenIZ is really a version 1 of the SanteDB platform, and it was using some older technologies that Medic had developed back in 2009 and 2010. SanteDB, in contrast, uses more modern .NET practices, such as using .NET Standard and NuGet packaging. Additionally, OpenIZ only implemented the parts of the HL7 reference information model which were necessary in order to facilitate immunization. This is different than SanteDB, which has a more wholesome implementation of the reference information model because it has to operate in different contexts. Another key differentiation between OpenIZ and SanteDB is that OpenIZ as a platform only had an app and this headless server. A lot of the maintenance and management and operational platforms were written as external tools around the OpenIZ platform. This is different in SanteDB based on a lot of the lessons that we learned in Tanzania. In SanteDB, the administrative user interfaces, the offline capabilities, and the server are leveraging a common platform and a common way of doing an implementation. And finally, OpenIZ had to run on very old and slow tablets, and because of this, it really limited our choice of APIs. In SanteDB, we've dropped all legacy Android versions and all legacy browser support. What this means is that we are free now to leverage more modern JavaScript APIs in our implementation of user interfaces and in apps. So now that the history is out of the way, let's take a look at some of the components in SanteDB. The first component in any SanteDB deployment is the Integrated Clinical Data Repository, or the ICDR. We call it the ICDR because there's only one of them per deployment per role of SanteDB in any jurisdiction. Its primary responsibility is to integrate data from different clinic sources and HIE sources to provide what we consider a longitudinal view of that patient's information in whatever healthcare domain or vertical that SanteDB is servicing. The ICDR has a lot of functionality in order to facilitate that role. Things like advanced data management features and master data management, versioning. It's got the central security repository and security architecture contained in it. It really is the key integration or keystone piece in any SanteDB deployment. The next major component in a SanteDB deployment is something called the DCDR, or the Disconnected Clinical Data Repository. The DCDR is primarily responsible with servicing end user needs within a deployment of SanteDB, and there could be thousands of these instances deployed in a jurisdiction. Really, the DCDR is concerned with synchronizing and presenting data in a way that's digestible to end users, and also capturing new data to feed into the ICDR when an internet connection is available. The DCDR is compatible with the ICDR in that if you write a plugin for the ICDR, it will operate, for the most part, with the DCDR. There is some caveats to that, but we'll get into that in a later video. So let's take a look at how these components fit together. As I had mentioned, the ICDR is deployed once within a jurisdiction. Now this might be a single server, or it could be a logical group of servers fulfilling the ICDR role. Now in a lot of health jurisdictions, there's existing infrastructure already present. A lot of jurisdictions already have provider registries, or facility registries, or user registries, and the ICDR is what integrates with these central infrastructure assets through the HIE, or the Health Information Exchange. Additionally, when you deploy SanteDB, you typically want to have some sort of administrative or centralized user interface to provide to users in order to manage the server. And this is deployed on something called the DCDR web portal. The DCDR web portal is really a DCDR instance which is tethered, that is, it's always online with the ICDR. But it really serves out the same user interface as a disconnected client would see. Now let's take a look at the offline options for deploying SanteDB's DCDR and user interface experience. The first option when you deploy a SanteDB instance is you can use the offline DCDR Android application. The Android application is quite useful if you're capturing data in the field and those users in the field don't necessarily have reliable internet connection, or their internet connection is very slow and it would impact user performance or user experience. The DCDR Android application is a complete replica of the ICDR functionality and a partial replica of the ICDR data, which only that clinic user is most likely to encounter in their day-to-day activities. For example, if you have a nurse that's servicing a particular village, her DCDR Android application would only download patient information of those patients which live in that village. There's a variety of ways that you can synchronize data from the ICDR into the DCDR, and it really depends on your use case and what type of data you're going to be capturing. Next, there are certain instances where having an Android application isn't the best tool for the job. Think of a larger clinic or a nurse with a larger cohort of patients, and she has to do a lot of data entry. Perhaps doing this on a tablet soft keyboard is not exactly a good idea. Also, the performance of a tablet might not compare with that of a laptop. This is where the DCDR Windows or Linux application comes into play. Like the Android application, the DCDR Windows and Linux applications are self-contained replicas of the functionality on the ICDR and a partial replica of data from the ICDR onto a Windows or Linux-based laptop. The DCDR Windows and Linux applications, again, are self-contained so that they contain the user interface as well as all the functionality in order to access and do things like business rules offline. Finally, you might have a larger clinic which needs to operate offline but has multiple users within a clinic that need to share data amongst a local area network. This is the deployment for the DCDR gateway. The DCDR gateway is, just like the DCDR Android application and the DCDR Windows and Linux applications, a fully functional replica of the ICDR functionality and a partial replica of the ICDR data to suit that particular clinic environment. Within this clinic environment or local area network, different instances of computers with a web browser can access the DCDR gateway locally, even if the clinic is offline. They can also see the data amongst each other in that offline environment in the clinic. Additionally, if that clinic is running a third-party piece of software such as World Vista or OpenMRS or DHIS2 or Oscar, you can actually communicate with the DCDR gateway just as if you were communicating with the central ICDR server. That is to say that the DCDR gateway provides FHIR and HL7 interfaces as well as OAuth interfaces in order to mimic the functionality of an ICDR, cache that data from the third-party EMR, and handle the synchronization without the third-party EMR having to worry. You can imagine this is a very useful feature if you're operating in, for example, an HIV clinic where you already have OpenMRS deployed and you just want to leverage some of the offline data capture that SanteDB provides you. Now that we understand how the different major components of SanteDB work together in a deployment, let's take a look at how we extend SanteDB. The first way of extending SanteDB is something called a plugin. A plugin is a piece of functionality written in .NET and compiled as an assembly, which is then loaded into the ICDR or DCDR application. These plugins are very useful for very heavy workloads. For example, if you want to expose a new fire operation, or you want to expose a brand new REST endpoint for a third party to call, you would use something called the plugin architecture. The next way of extending SanteDB is something called an applet. An applet is primarily intended for lighter workloads where you're just trying to represent a new user interface or a new report or a new business rule into the SanteDB ICDR or DCDR, and you don't necessarily want to write it or compile it and maintain it as a full .NET plugin, which is a little bit more complex. Applets are packaged and digitally signed, uploaded to the ICDR server, and then distributed amongst all the connected DCDR instances over the air. This makes it extremely easy to maintain and update new functions using the applet infrastructure. Finally, the last way to extend SanteDB is to just call the REST APIs. SanteDB provides a variety of standards-based and proprietary REST APIs which you can use to interact with the software. It's important to note that SanteSuite takes open architecture very seriously, and this means that there are no hidden functions. Have you ever went into a product before where you could do something in the user interface, but you couldn't find the REST API to do the exact same thing with your own user interface? That doesn't exist in SanteDB. Every function that the user interface, the admin panel, or end user interfaces performs that we write as SanteSuite, you also have access to on the REST APIs, provided you have the appropriate authentication mechanisms in place. Each of these mechanisms of extensions, plugins, applets, and REST API integrations can be packaged together in what we at SanteSuite call a solution. You can imagine a solution like a Lego kit. It has all the different bricks in the kit that you need in order to build a SanteDB product that suits a particular business need. And just like a Lego kit, you can bring your own bricks and add on to those solutions to further enhance the SanteDB solution to meet your jurisdictional requirements. Really, the goal that we're seeking here is a common reusable platform. We take the core SanteDB concepts, that is the ICDR and DCDR, and on those, we build a series of plugins, applets, and APIs, which we package together in different solutions. These solutions typically track healthcare verticals. So for example, SanteMPI is a master patient index which packages together the SanteDB core components with that component which is needed in order to fulfill the role of an MPI. Whereas SanteIMS, or the Immunization Management System, is a different collection of Lego bricks, essentially. Some of them are very similar to the SanteMPI ones, and that is a kit which lets you deploy an immunization system. And then further on top of that, each individual country can then add their own plugins and their own packages and applets on top of those solutions in order to further customize the SanteDB solution for their particular jurisdiction. In doing this, we ensure that we can readily reuse components between different instances of SanteDB software products. So in concluding, what you should take away from this video is that SanteDB has a long lineage and history in OpenIZ, Medic CR, and Medic SHR, and it really represents a version 2 of all of those platforms, incorporating the lessons that we've learned in trying to operationalize those previous generation software packages. You should also take away that in a SanteDB deployment, there's something called the Integrated Clinical Data Repository, or the ICDR, and that really operates as the central keystone system in the SanteDB deployment, and it is responsible for integrating with the other health information services and aggregating and coordinating data synchronization amongst the clinics, which have the DCDR, or the Disconnected Clinical Data Repositories, in them. And the DCDR is really the user experience, the end user product that they interact with to capture and view data, render reports, render business rules, etc. Finally, that SanteDB can be extended in a variety of ways, and those extensions can be packaged together to suit a particular digital health vertical, and that those can then further be extended by your implementation of one of those SanteDB solutions. Thank you for joining me and allowing me to introduce to you the SanteDB platform. You should check out our videos. We'll be releasing new ones every few weeks in order to further enhance your knowledge on the SanteDB platform. Thank you.